Hello everyone, in this video I am going to explain you the problem minimum number of steps to make two strings anagram. So basically in this problem they have given two strings of equal length and we have to take any character of string t and then we can change its character to any other character. So once we do this, in this we are doing one operation. So we have to return minimum number of operations to make string t and s anagram. So anagram is basically like there will be two strings wherein the characters present in both the strings will be same, but the ordering may be same or different. So let me take examples and then explain. If you see this example, in this case we have 2b but we have only one b, and we have one a and there are two a's. So this is not an anagram. So in order to convert into anagram, we have to change character of t. So once we change any character, that will be regarded as one operation. So let's take this b. So b is occurring here, so we don't need to do anything. Let's take a is also occurring here, so we don't need to do anything. Now thing is, this b and this a are not same, so we have to take character of t, which is a, and we have to change it to b. So while doing, we are doing one operation. So now if you see, the new string t will be a b b, so which is anagram to s. S is basically b a b. If you see here, two b's are there, here also two b's are there. Here we have only one a, here we have one a. Like frequency of the characters are same, but then ordering are different. So in order to make this both strings as anagram, we did one operation, so we have to return one. Let me take one more example. In this case, as you can see, let's take this L is not there in this case. Let's take E, so this E will be matched with this E, and let's take one more E which is not there. Let's take now T is there, this T will be matched with this T, and then let's take C, this C will be matched with this C. Let's take O is not there. Let's take D is also not there. Let's take E is also not there. So as you can see, like in these strings only 3 characters are matching, and there are total like string length is 8. So we need to change 5 characters of t. So basically 8 minus 3 will give you 5. So we have to change 5 characters of t. So this P or A, I see, we have to change it. So actually they have not asked to change this, but we have to return minimum number of changes to be made. So in this case we have to return 5. I think you got the problem. Let me take one more example and it will be very clear to you. This A is matching with this A, this N is matching with this N, again this A is matching with this A, this G is matching with this G, this R is matching with this R, this A is matching with this A, and this M is matching with this M. So here both the strings are anagram. So in this case we are doing 0 operations in order to make anagram, so we have to return 0. I think you got the problem statement. So I'll be solving this problem via 2 approaches. One will be the brute force approach and other will be the hashmap approach. As you have seen, like we have to store the frequencies, so I'll be using hashmap for that. So let me take first brute force approach. In brute force approach, what I'll be doing is I'll be taking a 2 for loop, which means we have a string s, we have a string t. Let's take string s is b a b and string t is a b a. So what I'll do is I run a loop from 0 to length of s. Since here both lengths are equal, so we can take anything. Also I'll take a loop which will run from j to 0 to j, 0 to length of, let's take s only. And we also take a variable which will keep count of how many characters are same in both strings. So here we will check if s of I, we will fix one particular this character and we will search through this string if that character is there or not. If that character is there, which is basically t of j, if that character is there, then what we'll do is we will increase the count of answer by 1, which means we have a matching there of this particular character position at I in S, and position at j in t. Once we get this, what we'll do is next time when we come here again b will be matched, but then here we have two b's, here we have only one, so we have to change this character to any other character which is not in English alphabet, so I'll change t of j to some dollar. And once I get like both the string characters equal, which means for this we have found this is the mapping, so we don't need to check further, so I'll break out of the loop. So this logic will give us the number of matching characters in string t and string s. So as we know, we have to return here like n is the number of length of the string, and then the matching characters are stored in answer variable. So there will be n minus answer unmatched characters. So these characters have to be changed in t in order to make both the strings anagram. So this will be our approach. I think you got the pseudo code. Now let me write the code. First I'll take n as size of string s or t, since both are same you can take anything. Next I'll take a variable answer equal to 0, which will count of match characters. Let me take match chars is equal to 0, which will make more sense like matching characters. I'll take a loop, I'll run from 0 to n I plus plus. I'll take one more loop which will check for that particular s of ith character is there in this t of j. You have to check if s of I equals to t of j, then we found a match character, so we have to increase match characters by 1, and this t of j has to be changed because next time that character should not match with other character. And once we found it, like once we matched, we will break out of the loop, and at last we will return like there are total of n characters and match characters are this much, so unmatched characters will be n minus match characters. So let me run it. It is running. Now let me submit the code. Yeah, so it used TLE because once you check the string s, so as you can see there are like 5 into 10 to the power 4 characters. Even if you select string t, that also has 5 into 10 power 4 characters. They have given in constraints. The string length would be 5 into 10 power 5 in max. So that is the reason, like 5 into 10 power 4 into 5 into 10 power 4 gives 10 power 9, and our constraint in most of the cases will be 1 second to run the code. So for 1 second, like input size will be max of 10 power 8. So since it is exceeding, it will give like 10 seconds. So it is giving TLE. Let us analyze the time complexity of the algorithm. Since we have a 2 for loop in our algorithm, and like for every character in s we are checking, so characters length on in s is n, and then each time we are checking like in worst case n characters in t. So time complexity is n square, and if you see space complexity, we are not using any extra space like hashmap or something, so it is of 1. Space complexity is fine, but then time complexity is n square, so it is giving TLE. So this brute force method is not working, so we have to find some optimized method only. So let's use hashmap approach. As you have seen in this question, it is related to frequency of the characters anagram basically, which means we have to find how many characters in both the strings are matching and how many are not matching. So what we can do is, We will take two hash maps. One hash map will store the frequency of the characters of string 1, string s. Other hash map will store the frequency of characters of string t. And we will go through the hash maps and we will check if both the hash map keys are equal. Then we will see which hash map has less number of characters. So that I will add to the answer variable, which will ensure that this number of characters are matching. And at last I'll do the same thing, return n minus answer. So let me tell you what I was saying actually. Let's come to this example. I'll store these characters in a hash map. So since b is not there, I'll insert b in hash map and then its frequency is 2. A is not there, I'll store in hash map and then its frequency is 1. This is map 1. By the way, we are using ordered map in this case because ordered map stores the key in ascending order. So we need it in ascending order only. I'll tell you why. Now let's take map 2. So A in this case are occurring 2 times and then B is occurring only 1 time. So we'll take 2 iterators which will point to the beginning element of the hash map, and it will find if those both keys are equal. If both keys are equal, we have to check which has minimum number of frequency. So as you can see here, it is 1. So answer variable first will be initialized to 0, then it is added with this minimum value which is 1, and if those both are equal, then we will move the pointer in both the maps to front, and we will check. In this also, as you can see, we have only like minimum is 1, so we will add 1. So as you have seen, like answer is 2 and then total number of length is 3 of string. 3 minus 2 is 1, so we are returning 1 as an answer. So in this case, basically what we are doing is we are taking this like in brute force approach we are fixing this element and finding if that element is there or not. But in hash map we will find everything like frequency of the element, that particular element we will having. So it will check like for that particular element, like let's say B in this case. So how many elements are there in both things? So it has 2 here, it has 1. So at max only 1 will be matching and other will be not matching with other B because it is not there here. So that is the case. I was taking minimum among these 2, and then when we move to A, so this is A. So here we have only 1, but here we have 2. But then at max only to the 1 element it will map. So that was the reason. Let me take this example and then explain. I think we'll get clear. So let's take map 1. This is M1. First L will be there, so L will go somewhere here. Let's say its frequency in this is only 1. Let's say E, and it has occurred 3 times, so its frequency is 3. So this E will be increased slowly. Then we have a T, it has occurred only 1 time. Then we have C, it has occurred 1 time. Then we have O, O will come here because it is an ordered map and it has occurred 1 time. Now let's take D, it has occurred 1 time. So if you add these frequencies, you can get like 8, 5 plus 3, 8. In the same way, we will take one more hash map, map 2, which will store the frequency of this T. First is P. So we have P here and then it has occurred only 1 time. Next we have R. So R has occurred 1 time. And then we have A. A has occurred 1 time. Then we have C. C has occurred 2 times. Then we have T. T has occurred 1 time. Then we have I. It has also occurred 1 time. And then we have E. It has occurred 1 time. So when you count this, like 3, 5, 8. So in this case, again same thing we will doing. We will point to the beginning element of the both hash maps. In this case, as you can see, here we have A, here we have C. Since C is greater than A in ASCII code value, it is 97, and then it is 97 plus 3. Sorry, 97 plus 2, which is 99. so it has a greater value. Since these both are not matching, I'll move only this pointer to this thing, so that basically we will be finding if these both are not equal, we will move the pointer which has lesser value, so that in future we might get a key which has equal value. So in this case, as you can see, both C's are matching, so our answer will be first initialized to 0, and then minimum among this is 1. So once both the characters matched, both the pointer has to be increased. Now as you can see, E is greater, D is smaller, so we will move forward this pointer. So E and E are matching, but then small, like minimum is 1, so only one will be mapped, and rest 2 E's will not be mapped. As you can see, like let's say this E is mapped with this E, and this rest 2 E's will not be mapped with any other characters. Since both are matched, we have to increase both pointers. I is smaller than L, so I have to increase this pointer. We have L and P. L is smaller, so I'll increase this. O is smaller than P, then I'll increase this pointer. P is smaller than T, I'll increase this pointer. R is smaller than T, then I'll increase this pointer. We have a T, and minimum value is 1. So as you can see, like we have only one T, and then one T is mapped with the other T. So as you can see, a total of 8 length is there, but then answer we have got, like a mapped answer we have got is only 3. So the unmapped characters are 5. So this is the answer we have to return. I think you got the problem statement clearly. Now let me write pseudocode for this approach. First I'll take a hash map, let me call m, and it will take 2 data types. The key data type is of character type, and then frequency will be stored in integer data type. Let me call map1, and then also let me take map2. I'll run a loop which will run from 0 to length of s, or you can take TL as well. And in map1 I will store the frequency of string s. I'll increase it by 1. In map2 I'll store the frequency of string t and increase it by 1. So this line of code basically stores the frequency of each character in s and in t. And I'll take one iterator, let me call same thing hashmap iterator, whose key type is character, frequency type is integer, and let me call iterator 1, iterator 2. This both iterator will be pointing, like this first iterator will be pointing to map 1 of begin element. Similarly, this will be pointing to map 2 begin element. Now we have to check if that both iterators are not pointing to the end. Like iterator 1 not equals to m1 dot end. Also iterator 2 not equals to m2 dot end. Like till we are pointing to the hash maps, we need to check. If any hash map crosses its key value pair, then we have to return out of the loop. Our first condition was, before that we need to take answer variable and store 0. This answer is basically match characters. So if iterator 1 dot of first, for first let me call f, is equals to iterator 2 of first, which means both characters are matching. Now we have to increase this answer variable by minimum of iterator 1 of second, which will be the frequency. Similarly iterator 2 of second, for second I am writing s. So if both the characters are matching, so in that case we have to increase both pointers, iterator 1 plus plus, iterator 2 plus plus. Else if, let's say, iterator 1 of first, which means the character at first hash map is greater than iterator 2 of first, So this, since iterator 2, which means map 2, has a lesser character, so we need to increase iterator 2 by 1. This is else if. Else it is implied that iterator 2's first character will be greater than iterator 1. So in that case we have to increase iterator 1 plus plus, and when we come out of this loop we have to return length of the string, which is n minus matching characters which is stored in answer variable. So I think you got the pseudocode, and then let me write code. So first I'll take size n is equal to, you can take anything s or t, and then I'll take a map whose key value is character and value or frequency is of type integer. Let me take m1 also m2. I'll run a loop and I'll go through one by one all s and t elements and insert into the hash map. m1 of s of I, m1 is basically storing the frequency of character of s, m2 is storing the frequency of character of t. Now I'll take a iterator. So let me call iterator 1, which will point to map 1. Let me take iterator 2, which will point to map 2. Now till we have a key value pair in hash map, which is basically iterator 1 not equals to m1 dot end and iterator 2 not equals to m2 dot end. So we need to check our conditions. First condition was, if iterator 1 of first, means that particular character string, the character present in string is equals to the character present in t. So in that case we have to take one answer variable. So this answer variable has to be increased by minimum value of either iterator of second or iterator of 2 of second, and we have to increase both the pointers. Else if iterator 1 of first greater than iterator 2 of first, which means the character present in string t is less, so we have to increase iterator 2. Else it is implied iterator 1 first will be smaller, so I have to increase iterator 1, and at last we have to return the size of the string minus match characters, which is stored in answer variable. Let me run. Let me submit the code. So it got accepted. Now let us analyze time complexity of this algorithm. As you can see from here, like we have one loop which goes through the entire string s and t, which will take O of n time complexity, and then we have a hash map, like basically we are checking the matching characters. So in worst case, let's say string s and t, both characters are different, characters are distinct, always different. So in that case this loop will be executed O of n plus n, basically 2n times. So as you can see, time complexity is boiled to asymptotically it is O of n, from n square it is reduced to O of n, and then space complexity is reduced to, as I said, like in worst case, let's say in a string s all characters are distinct and the characters are not matching in both string and t. This will not be O of n because we have a character, so we know that in English we have only 26 characters, so it will be like 26 plus 26, which comes out to be 52, so it is constant. Similarly, space complexity we are using, like in worst case we will be using 26. Also let's say all characters are distinct, like all 26 characters there in string s as well as string t, so it will be 26. So it will boil down to often. So the space complexity is good only, and then time complexity is drastically reduced. So in this way you can solve the problem. Thank you for watching.